Hello, calculus students. In this problem, we have to find the equation of a tangent line. So first thing I'm going to do is write the equation of a tangent line. Well, actually, I'm just going to write the equation of a line. And we'll make it a tangent line in a moment after we find the correct slope for this. All right, so the slope of a tangent line, which I will denote by m tan, is given by the derivative evaluated at the point that's given here at x equals 1, so that's going to be m tan. So I need to find f primed, and then I need to plug in 1, and I will get the slope of the tangent line. So let's go ahead and do that. So let's see, I have f of x equals pi to the 3x plus 2. Now, to differentiate this function, I have to use a logarithmic differentiation. So what I'm going to do here is I'm going to take a natural log of both sides. And the reason we do this is because there's this beautiful property of logs that the exponent gets multiplied by the logarithm, like that. So you could think of it as this exponent dropping down, almost like a derivative. Okay? And now I'm left with this constant, natural log of pi. Alright, so now I have that the natural log of f of x is equal to this expression here on the right. Okay, now I'm ready to differentiate. Okay, so when we differentiate the natural log here, we get 1 over the argument, which happens to be f of x, and then by the chain rule we have to multiply by the derivative of the argument. And then when I take the derivative of the right hand side, I'm just taking a derivative of 3x plus 2, and that's simply 3. And the natural log of pi is a constant, which factors out of the derivative. So now I want to find f primed of x, that's this term right here. So I'm going to multiply both sides by f of x, and when we do that, the f of x ends up over here. But keep in mind that f of x was equal to pi to the 3x plus 2. So that means that f primed of x is equal to 3 natural log of pi, which is some number, times f of x, which is pi to the 3x plus 2. Okay, so now that I have the derivative, I want to find what m tan is, the slope of the tangent line, so I will plug 1 into the derivative now. So let's see, I have f primed, and then I'm going to evaluate that at 1. Okay, then I will plug in 1. The only argument there is that 1 there, and that leaves us with 3 natural log pi to the 5th power. Alright, so that's f primed of 1, and that is our slope, which I'll denote by m tan for slope of the tangent line to the curve. So now that I have the slope here, I know what x is. I need to find out what y is. But remember that y is given by f of x, so the y naught is given by f of 1, which is simply the function evaluated at 1. So if I plug in 1, I get that y naught is equal to pi to the fifth. Okay, so let's see, I have all the information I need, and I have the equation of the line. So now this will become the equation of a tangent line. So let's just carve out a little spot over here. So let's see, we have y minus pi to the fifth, because we want y naught, and that is equal to the slope, which is given by 3 natural log of pi times pi to the fifth times, let's see, x minus x naught, which we were given is 1. And that is the equation for the tangent line. Sometimes you might want to push the y naught over to the other side. You'll see this sometimes if you have to enter in the equation of a line. And from this point on, you could write it as mx plus b, where you'd have an intercept, but I'm going to leave it just like this. To get it into mx plus b, you just distribute the slope here, and then the b terms becomes the slope plus the y naught. Or I'm sorry, minus the slope plus the y naught. All right, good luck.